Alright, getting into some activities that you can use on your own and also for future quizzes. We're going to focus on gauging and watersheds and how we diagram stream orders. So I want to just start off with this question that you probably didn't know, which is a hydrograph and which one is a hydrograph. So over here on the left, we're measuring precipitation and intensity, and the precipitation intensity is in millimeters per hour. And over here, we're measuring the gauge height, which also corresponds to an actual discharge amount in cubic feet per second. But the gauge height's kind of the height of the river, and it's over time. So which one's the hydrograph and which one's the hydrograph? So hydrographs are measuring water, and then hydrograph is measuring precipitation. So it's just good knowledge to know on the vocabulary side. Now getting at urban versus forested hydrographs, and this is just some sample one that I've kind of put together for you. Which one's the urban hydrograph and which one is the forested hydrograph? So when it rains in an urban landscape, what happens to the water? It runs off quicker into the water, right? Which would cause a larger spike or surge, and then the water goes down. And when it goes down to the point that there's virtually no base flow because there's no groundwater to feed the stream or the river. In a forested landscape, a lot of rain falls and a lot of the water is absorbed by the soil, and the forest roots take up a lot, and the forest landscape sucks up a lot of the water, and it also gradually releases it over time, so there's always a little bit of flow. So the big spike is more of an urban watershed. If you want to know what an urban watershed of the most intense sense may look like, we can look at the Los Angeles River, or if you look in Cincinnati at Mill Creek. These are rivers that are actually impervious beneath them because there's poured concrete in which they flow. So I'm going to pull up a couple pictures here for you. So we're just going to do a little clip from the Terminator 2 movie, and this is a scene in which Terminator 2 is chasing this guy on a motorbike through parts of the Los Angeles River, which is an impervious surface. So you know, that's an actual river that is completely encased with concrete. And then here we have an image of Mill Creek near Cincinnati's Metropolitan Sewer District. So Mill Creek flows north to south, pretty much along I-75 from the north side of Cincinnati all the way to the Ohio River, and comes out just west of downtown Cincinnati. So more of an impervious watershed in the truest sense. So with respect to it being impervious, it's not just the banks that matter, it's also in the land uses around. So if it's a lot of parking lots and old industry, or just industry in general, and buildings, that will make it behave more like the urban watershed depiction, where it's more flashy in terms of how quickly it might have a flood without adequate stormwater controls in place, and it also can go dry a lot quicker over time. With regards to monitoring stations, when we pulled up this, you can get USGS information on flow for a lot of waterways anywhere in the United States. You could start off by just doing a simple Google search and say, I want to know what the Dix River is doing there coming out of Harrington Lake down near Danville. And you can actually just type it in, and it takes you to the USGS Water Science page, and the Kentucky River Authority, the Energy and Environment Cabinet for the state, and Kentucky Utilities provide support for this gauge station that exists. And you can see the gauge is reporting it here in discharge in cubic feet per second. And this particular lake is a hydropower lake, so it's important for KU to probably monitor it because they can use that lake for generating hydroelectric power. You can just type in water data USGS and search water data for the nation, and then you can just look at the water levels. I'm going to type in click on current conditions, and you can see the blue dots show areas that are running really high right now, and the black are like really high. Blue dots are like, you know, top 90th percentile. Black dots are like a pretty extreme event, to say the least. The black dots probably correspond with some of the movement of the hurricane that passed through, coupled with a lot of like the humidity and rain and all that. It's weather, and you know, possibly climate induced as well. You can click on any one of these dots. We're going to click on Kentucky, and on Kentucky I can pull up the stream flow conditions for a lot of places. Here is the Red River at Clay City, Kentucky. I click on it, it'll tell me who manages it as well, the Kentucky River Authority. The Kentucky River Authority actually, you know, there's still a little bit of transportation on the river, and there's recreation on the river, but they also are involved with wastewater treatment, making sure that our wastewater plants are flowing. They're also involved in drinking water. So the Red River at Clay City, Kentucky had a pretty good amount of rain, it looks like, on the 31st. And then you can see the discharge in CFS. If you wanted to look at the discharge in terms of gauge height, you can see it there in gauge height. Notice the gauge height mimics the actual discharge for the river, because those two things are similar. This is information that is also available below a lot of the dams. If you were to go towards like Moorhead, the Cave Run Lake, the dam, the Licking River has a USGS station just below the dam, so the U.S. Army Corps of Engineers operates it, and you can see these big fluctuations, and this is water temperature related to when they're letting water in and out of the dam. Here's how much rain they had at that station. The gauge height, you know, it goes down and up, corresponding with the releases of the dam. This is gauge height in feet, but the gauge is also synced up, at least for the Corps of Engineers, in cubic feet per second. So it's just a little bit about getting information from those gauging stations. So now we're going to talk really quick about watersheds. So what makes something a watershed? So watersheds are usually those high points, and watersheds can be small, they can be big. They're inclusive of a lot of smaller watersheds. Many of our Kentucky counties have boundaries that are based upon like topographical features or watershed boundaries. Like when you cross a bridge, when you cross the Kentucky River from Madison County into Fayette County, you're crossing that bridge, that's the county boundary. The Kentucky River is the county boundary. When you're heading south out of Madison County into Rockcastle County, when you cross that ridgetop on I-75, you see the now entering Rockcastle County. That ridgetop, like many counties, it serves as a watershed boundary as well. So the water on that side in the Rockcastle County flows into the Rockcastle River, and on the other side of that boundary, you know, it's flowing, you know, northward. And I don't remember, it's like Paint Lick and Silver Creek watersheds. So, all right, we'll cover the other factors related to flooding later. Moorhead, Kentucky, this is Rowan County. So this is the North Fork of Triplet Creek. You know, this is like the Triplet Creek boundary here. That's the North Fork. This is the main fork of Triplet Creek. This is the high point that separates it from Lewis County. Everything over here flows up into Tigard's Creek in Carter County. Everything over here, I think, flows like Hinkston Creek and Fleming County. This is the Licking River. It's the low point in the county. So, you know, again, you can see this whole county's boundary represents the ridge tops, because ridge lines were easier for people to identify back in the day. So in the hills, we can see these. We call these ridge lines. If you were to go out west to like Kansas and try to separate a watershed one from another, it's so flat it's hard to see with your eye, but it still serves as a dividing point. Ridge lines in the east serve also as divide lines. Out west, even the big divide lines are ridge lines in some cases. Like Rocky Mountain National Park sits on the Great Divide. So everything west of the Rockies flows to the Pacific. Everything east of the Rockies, east of the Continental Divide, flows to the Gulf and Atlantic. So divide lines, ridge lines, you can kind of use those synonymously, but in Kansas and Nebraska, they're not apparent ridges. You can't see them. There are a lot of river basins in Kentucky. This is the Kentucky River watershed, kind of this outline here of the blue. You know, essentially from Virginia, Southwest Virginia, all the way up to where the racetrack is up there in Carrollton, northeast of Louisville, is where the Kentucky River flows, which provides water for Irvine, water for Richmond, even Fayette County draws from it, flows through Frankfort. So there's a lot of sub-basins within it. You know, you have South Fork, Kentucky, Middle Fork, North Fork, you know, Red River. So there's a variety of sub-basins. In the east, watersheds tend to have a dendritic pattern. Dendritic comes from the word like dendro, like tree. They have these tree shapes. Some people know the term dendrites from like neuroscience or neurology or something like that, because dendrites, our nerves, they have these shapes. And that shape, dendrite, like our nerve cells, those actually come from like a tree type shape. So we have dendritic watersheds. And on a topography map, the closer the brown dots are, or the brown, not dots, but the brown lines or the topography lines, these elevation lines, the closer they are, the steeper these areas are. So if you were to go near the Red River Gorge, you'd see a lot of steep lines. On this topography map, there's a lot of brown here, and these are deeply furrowed kind of forks of a creek called Cabin Run. The big watershed for the East Fork of the Maumee River in this case, it's really hard to see these boundaries when you start getting out to a bigger watershed, but these sub-basins are pretty easy to look at. So getting at our watersheds in the United States, our big ones, the Mississippi River Basin, it includes the Ohio. Some people actually argue, I can give you the paper, that the Mississippi actually, in terms of the volume of water that comes down these and economic output, because of the way the weather patterns had been, the Ohio River actually, some people say, is what should carry the name, not the Mississippi River. I'll send you a paper on that. The Ohio River Basin actually includes the Tennessee River Basin because they join before it meets the Mississippi River. The Tennessee River and the Cumberland River form like Lake Barkley and Kentucky Lake. You know, some powerful rivers with a lot of hydropower potential behind them, a lot of jobs, a lot of tourism associated with the lakes in those valleys. The Ohio River Basin includes even parts of Virginia and parts of New York. So, a very large river system. All these waters flow into the Gulf of Mexico at the delta, where there are distributaries that distribute the water into the Gulf. There is the hypoxic zone you see here, where the nutrients, and we'll get more into that in the second chapter, create situations where the flora that live in the Gulf suck all the oxygen out of the water. So again, the Ohio River Basin, and again, it includes the Tennessee River Basin. So the Ohio River Basin itself includes, you know, parts of Alabama and even Mississippi into the basin before it meets actually at the Mississippi River in Cairo. So Kentucky's got its fair share of big watersheds. We'll get more to those later. We've got many around the campus. So how do we number or label watersheds? I think I'm going to make a video on that particular topic here so that we're familiar with how to do stream ordering using the Strahler method. So getting at some review questions. What do Europeans call watersheds? I hadn't told you guys that yet, but they often refer to it like a baseball glove. They're catchments. So if we were to pull up a picture here, I'm going to pull up a picture here in a second. We'll get that here. Let me just pull it up. I've done quizzes like this in the past with respect to watersheds, and I've said this dotted line here, it's not an intermittent stream, it's the high point separating this section over here from this section. What would we call this line? And the best answer would be a divide line, or a ridge line if you're in the east, then it's visually apparent. What stream order are like 1B and 1A? You're not going to know the answer to that because that's the focus of our next video.